I'm the backup speaker. Up until like an hour ago, I didn't even know that we're going to give the presentation now. So please bear with me. I just shrunk the talk down from 45 minutes to 25 minutes. I'll need to rush through some slides, so hopefully it will work. I guess so. I've given the talk already. Given the talk already a couple of times, but for a longer slot. So, hi, I'm Christian Heimes. I'm from Hamburg, just arrived yesterday from Germany. I'm a Python core developer maintaining the SSL model, hashlab model, and work on the security team for Python. I make money by working for Red Hat as a security engineer, working on a software solution called FreeIPA and DocTech. Yeah, so what's this talk actually about? So short agenda and goals, what you're going to learn here. First, I'm giving you I have a screen down there, fantastic. Motivation, so why should you actually care about security? What does security mean? Some honorable mentions and fun facts, how to design your software security from bottom up. And then finally, the longest slide is going to be a couple of examples, mostly Python examples, and things we discovered in Python core the last couple of years and security issues. And finally, short summary. So this talk is mostly in breadth, so don't go into any specifics and details very low, but yeah. So why should you care about security? Well, actually, so for me, it's mostly, I consider myself as a proud craftsman and responsible engineer, so I don't want to develop a bad solution. I want to do something that I'm proud of and not get laughed at when I do something. But there's also for people who are like on a manager level, also a big business case for security. So not sure if people know what Yahoo is. Most people are rather young here. So a couple of years ago, Yahoo was hacked. They got like 1 billion accounts compromised. Actually, it was not like 1 billion, but yeah. But about that time, Yahoo was also considered to be bought by another company. And the stock price fell a lot. And, 3 billion accounts, actually. And so Verizon wanted to buy Yahoo, and they got a discount of 350 million off the actual transaction. And if you have 350 million bucks off, well, I can give you my account details. So one thing you should actually care about security because it's a lot of money involved. And like last year or beginning of this year, actually bigger transaction where a company lost a lot of stock price. That was the Facebook hack, where Cambridge Analytics was revealed what's going on, and Facebook lost a lot of in stock market price. It's also security in some areas, life and death situation. So I haven't been to Karen's keynote this time, but I have been to her keynote half a year ago at PyCon Czech Republic, where she talked about her pacemaker. And yeah, pacemakers can get hacked. And if you have to replace a pacemaker because there's a software security issue or a design flaw, you have to cut people open. And if the pacemaker malfunctions, get compromised, they can actually kill people. Other storylines, well, a couple of years ago also the Ashley Madison hack, which adultery side, very shady business, where later on people committed suicide. Or there are several countries where the website was also used by non-traditional marriages to find partners, and in several countries people were in danger of torture and even facing death penalty, because in some countries, these red mark countries, actually India has changed just recently. If you are not living in a traditional relationship, you can get really, in a pickle. Well, security is also that one. I'll give you a moment to read that. So, this conference, lots of new conferences over the last couple of years got a code of conduct, and security is all about keeping people safe and make people also don't jeopardize their lives. So what is information security? So there's a Wikipedia definition, which is rather good. I like Wikipedia for short definitions. So information security is the practice of preventing unauthorized access, use, disclosure, disruption, modification, inspection, recording, or destruction of information. It's how to keep information safe. What this definition doesn't include, what I like to include, is also privacy. Keep the information of people private. And when people talk about security, well, they want some also well up. It's not about worrying about post-quantum computers. It's more like the simple stuff. So because in most companies, if you start with simple things like choosing good passwords for your FTP server, or don't use FTP at all, you can have a much more bigger impact than worrying about stuff that's not relevant yet. So why is it actually too hard to make something secure? Well, computers are very complex software, complex systems. And if you have a very complex system that is tightly interlinked, the weakest link can just cause your whole system to crumble down, like this Jenga tower. And it's very hard to test for security. You can often only test for things you know that can go wrong, but you don't know any kind of specific security issues. Then it's very hard to test that. So you can't write a test case that will fully exhaust all your problem space and give you the benefit of the doubt that you don't have security issues. There are ways to do that for very narrow problems, but that's crypto, very hard. I don't know how it works actually. We have also lots of design issues because with the way you design software these days is a way that tightly interlink different components. Microservices can help a bit, but they introduce other issues, well. And there's so much ways that stuff can go wrong. And to analyze that is also very hard. So one of the things that somebody else also gave me the feedback for another talk I gave at DEF CONF India is when you are into security, try to increase security, you also get bigger backlash because anytime you try to improve security, you basically introduce a breaking change. You break an API, maybe in a way that was never designed to work like that, but you have to restrict or remove features from your software. So just to give you an example how other industries work with that, because there's much more than the software industry. There's one industry that's very, very good at handling security issues at all. It's the airline industry. So 2017 was the safest year for the airline industry ever since we have commercial flights. There's no crash of a big commercial airline. It included a flight, Air France flight, that lost a complete engine over the ocean. The engine got lost, dropped down, was destroyed, and nobody got hurt. Or other issues, let's just say, so that's an engine failure again. And in that case, one woman got sucked out the window, but she was the only one who died on that flight, although it looks pretty scary. While we as a software industry, well, there was like last year, 1.5 years ago, where one Amazon guy just typed in the wrong command on the wrong window, and he just brought down like a third of the internet. We don't do good testing. The airline industry tests their equipment very good. So it's a bit hard to see what's going on here, but that's the hull, and you see the tip of the wings. That's the blow-up, wing-up test, and that's a safe condition for an airplane. So if you're worried about flying, so that's a very extreme situation, but it's tested, well understood, and they know what's going on. While software industry, you can actually do something like that. So you encrypt something, somebody else uses a microphone, listens to your computer, and can actually see what's going on. Because computers and software and hardware, so that's a hardware attack. They listen to how different sounds a CPU and the voltage stabilizers do. Because CPUs are complex beasts. This is a slide I had in my first security talk almost over 5 years ago, explaining like an older version of a CPU. And people think, oh, CPUs are probably fine. Hardware vendors are taking care of security. Yeah. Roham and Spectre were attacks that came out, I think, last year, the first versions. They're still finding new ways to break out of sandboxes and to use different ways. So CPUs these days make programming and calculation very fast, but also open them up to timing attacks. But it's not just the back end. The front end, how we interface with users, is also not very good. So this is one example from a user interface. So these are two different strings, what they look like. Well, what's going on? Well, because we have much more languages, so that's called a homoglyphic confusion attack, where we just use Russian letters and Greek letters in there. And user interfaces, another one that hopefully nobody was affected about that was the Hawaii incident. We had a couple of, I think half a year ago, I'm not sure, where they designed a very bad user interface which was easy to confuse. The operator, instead of issuing a test alarm, issued a real alarm, and they had no way to back that out. And that's actually on the right side a screenshot of the user interface. And so if you're working in security, working with users, one thing you should actually change your mindset is please stop blaming the users. Don't try to fix the users. Fix your user interface. Fix the way you interface with your system. Because you can't change the user. You can educate them, but you should write your system in a way that makes it hard for the user to do something wrong. Okay, before I go to examples, some honorable mentions, so things I can't cover because it's just a 25-minute slot. So there's lots of ways to security infects, starting from legal issues you may have interacting with the European Union, privacy shield was a big thing, hardware security, we quickly mentioned browsers, and web security is totally not my area of domain. I have very narrow information knowledge of what browsers actually do, how JavaScript security works. Ransomware, state-sponsored actors, cyberware, and terrorism. Political things. But one thing I wanted to point out, so one of the biggest, most dangerous terrorists we have that attack infrastructure, they're one. Looks cute, but he's super dangerous because squirrels are actually the ones that keep on destroying power grids a lot. So they try to jump on transformers, and these numbers I pulled up in the morning. So there was 1,228 successful cyber squirrels attacks on power grids for the last couple of years. So if you go to the website, there's a map and shows the location and shows the incident report of every kind of these attacks. And humans are just here, and the threes with a star. So it's fun. So terrorism is mostly dangerous when it's animals. So humans are also, going back to the user interface quick, social engineering. It means you do something to trick a user to do something the user actually doesn't want to do, or, for example, getting like millions of dollars from a CEO scam. Users like to chocolate a lot, and there was a study that almost 50% of people give out their company passwords for a good piece of chocolate from Luxembourg. Yeah, well. Dissatisfied employees, so most people tend to think people working inside a company are safe zone and any outsider is dangerous. But if you have somebody who's not satisfied with the company, just can download stuff on the USB drive, walk out. So Edward Snowden is maybe you know the name. Ignorant management is on the other side of this balance. If you have managers that don't acknowledge security issues, well, we can't change the system. Usability. People find a way to work around, like you can't do a screenshot. Well, it's an old picture, but yeah. Internet of Things. This is my German humor. So I gave that talk a while ago, and somebody who's taking care of IoT at Red Hat approached me afterwards, and he, oh, it's my alarm. He's a manager, IoT, oh yeah, did I tell something wrong? Now he told me, good thing is, if you have IoT devices, please put them in a closed environment and don't let them actually talk to the rest of the network. And people learned that the hardware here was a casino that got robbed by a thermometer in a fish tank. They stole the information about the high rollers and, well. So, design and security bottom up. You want to get, design a system, you want to first get trustworthy hardware, which is a big issue. You want to validate which operating system you install or the software. You probably want to have, secure booting, firewalls so don't expose the services outside. Please install the updates and use SL Linux. And why did I say that getting trusted hardware is an issue? Not sure if you saw the news last couple of days, Bloomberg, an article about probably Chinese government, who added a very small device. You can actually not see this small thingy between the BMC and the flash. So that's the control on the motherboard. And that one was in the path between the UEFI interface and the base controller. And they used that to hack computers. And this is the company builds motherboards for most of the servers. And again, applications, don't run them as a root. Please try to restrict your applications to have less capabilities. Encrypt everything, helps a lot. And don't expose your services to the outside. Authentication, strong one. And update. And you update software, you have to restart your software. If you update the kernel, you have to restart the computer. And all these measurements, one thing alone won't help much, but if you combine them, you get something called defense in depth, like this old fortress. We have lots of areas that if you even compromise one part, you can probably not get to the next part. And finally, again, please update. Don't be Equifax. You see, US company who got compromised most of the customer data because they didn't update their software. So, going down to examples and the Python components. I have still 10 minutes to go. Perfect. So, good thing is about Python, like Go and Rust, it's a high-level memory-safe language. It means most of the attacks on a low level, if you write C code, are not that happen that often. So it's mostly issues I have to take care of as a Python core developer because I actually write more C code for Python than Python code. But there's still several things in Python that are rather dangerous, like these functions. So if you allow people to execute random code on your computer, and importing is also executing random code, and even pickling, if you load a pickle from an untrusted source, that actually also executes code. You can use that to import other code and do nasty things, so don't do that. C-types also, with C-types you can get the same issue you have in C. You can have to take care of pointers and memory allocations and resources, and be wary. There might be trap holes. So now, examples. So some things we had in the Python core development team I've been in the security team for 5-6 years now. And one thing we had, for example, was something called a directory traversal attack, where if you don't validate which file names you get in, then you can do something like that, where you can walk to a different path. And this attack, combined with loading, executing models from different paths, was used to attack the wiki.python.org, I think 5 years ago, where an attacker completely compromised and later on killed the wiki. And we later learned that we didn't have any proper backups, so several people restored wiki.python.org from Google caches and archive.org. Yeah, mostly. So we didn't recover all the information, but most of the information. Other thing is, if you do work with files, there's something called a time of use attack. So TOC2, time of check, time of use, or a race condition. So if you do something like checking if the file exists, and then do something that condition, that's not safe. Because computers have threading and have multiple processes and multiple users working on. And between the time of check and time of actual use of the resource, somebody could snug in additional files. So you need to use something like exclusive opening and closing, where the operating system guarantees you that you, for example, don't create a new file and then catch the exceptions. Working with temporary files and directories is also something I find rather often when I review code and check for security issues. Don't assume that the temp file directory is like secure place. You can make it a secure place with special APIs, and so the temp file model takes care if you create your own allocation that's safe. But yeah, and if you use software like systemd, it will allow you to create an isolated temporary directory that just for your application. Parsing files is something we had several fun with. So HTTP is a format used in transferring HTML and other content over the web. So the most important format. You have two blocks. You have like a header block. It's like something, colon, something, and then new line. And then it is an empty line, and then the actual content starts. And to parse that, it looks actually simple on the first glance. So you make a connection, you iterate over the lines, you split the lines, and when you find an empty line, then you stop, content starts. But that's vulnerable to a denial of service attack. And that place, because you load, so for line in something, loads the line until it finds the end of line. But if an attacker never sends an end of line information, then you can just fill up the memory. And especially if you add gzip compression to that, and you send just null bytes and null bytes and null bytes until like you fill up the memory of the server and kaboom. So we had that issue, almost 5 years ago. Wow. Time has passed fast. Where you just, instead of iterating over the file, you have to do some extra lookup and load a limited amount of bytes. If you go over the line, then you fail up. XML security is something I popped up a couple of weeks ago again over the Python core developer meetup in Seattle at Microsoft, and I was asked and forced to work on that kind of security again. Just very quick, XML has some extra features called entities, and if you can do entities in a way that can be like referencing other entities and that can blow up very fast, yeah. Or you can load some other resources, even load like files from the file system that can be used to bypass even firewalls. So you can send some XML file and probe around the network, do even SSH tests. It's fun. And there's a lot of things that can go wrong in XML. I wrote this diffuse XML, which I'm going to retire now because in the next version of Python 3.6, 3.7, and 2.7 will have a fix for most of the issues, and also currently hacking on the XML-C parser to fix more of the issues. Even something harmless at first, like getting translations, can be used as a DOS attack vector, because you have something called plural forms. So English, Italian, German have the same way you can do plurals. So the 0 and the 2, 3, 4 are the plural form, and the 1 has a different form. French is a bit different. Celtic gets a bit more complicated. Russian is much, much more complicated. They have multiple forms. Or that one is if you take like a couple of times to power something, it turns out to take a long time to calculate and consumes lots of memory. Regular expressions, if you pass something with a regular expression, there has been an attack that came out at the beginning of the year. You have to be very careful how you create your regular expressions. And depending on which computers you work, there have even been a recent attack where they used constructed DNA to hack DNA sequences. So 3 minutes, I'm going to rush a bit. Input validation, so SQL injection attack, probably you heard of that. Don't construct your own query strings. Use a system like Django has a ORM layer, or SQL Alchemy has an ORM layer, so that one is bad. Same as also if you run sub-processes that can be used to do bad stuff like removing all your files. And there's lots of other ways. So even like modern JSON-based database, NoSQL databases can be hacked that way. And finally, please use TLS SSL. So encrypt your traffic and enable verification. It's something I will hopefully make as a default in Python 3.8 to enable verification of certificates by default. And don't run your, use Let's Encrypt. And don't run your own cert validation. It's something I thought a while ago until we finally was able to drop old version as OpenSSL, which got me lots of hate mails too. I can tell you stories later. So stay here a couple of days. If you want to talk to me later on, just grab me in the hall. And yeah, that was that one. Sometimes it's nice. So I found that issue in LibreSSL before it actually hit the public and was used wildly. And got even a CVE and a bug bounty for that. And finally, if you do something with crypto, please don't roll your own crypto. It can go wrong so many ways. AES encryption may look secure, but if you use the wrong mode, you can actually see the content. It's a logo of PyCon UK. And do something ridiculously, like there was a small error in the Go library. That's a lot of zeros behind the dot. And even that one small error could be used to reconstruct and crack a private key. But you can actually implement it yourself to learn about crypto, but please don't use it in production. And finally, I probably can't explain that all. We use a proper random number generator because the default ones are, if you use a random module, it's usually insecure. Use a proper hashing algorithm for your passwords. And if you don't need that, you can try to use a social login. It's usually much easier for the user. And don't use bad crypto. And don't pass security tokens insecurely. And don't hard code your keys in your application. There was a fun attack a while ago. Yeah. For a run of time. So educate your users. Please reuse existing software and libraries. Restrict your applications. Encrypt as much traffic and data on the disk as possible. Update your systems. And please consider privacy. And if you want to learn more about crypto and security, so these are 2 books I really like. Easy to read for most people. And just contact me on Twitter and by email if you like. And yeah, thank you. I'm actually in time. And no time for questions and answer. But again, I will be here until, actually in New York until Wednesday. So we'll do a bit of sightseeing, touristy stuff. First time for me at the East Coast. So thanks for attending. And that was a backup talk. So for you in the probably came late on, I just learned about like 1.5 hours ago that I was giving that talk. So sorry, it's a bit rough on the edges. I hadn't had time to practice that talk in a shorter version. So thank you.